This session now is about measures of central tendency. As we have discussed that there are three types of measures of central tendency. One is the mean, the median, and the mode. Now initially let's discuss with the first measure of central tendency called mean. So let's, for example, say I have a score. Say for example I have a score of runs which a cricket player makes in every over. In a 20 over match, let's say the cricket batsman A or the team makes in the first over 20 runs, 15, 12, 6, 9, 5. So like this, if I have a 6 over match in which in each over I have made in the first over 20, in the second over 15, in the third over 12, fourth over 6, fifth over 9, and sixth over 5, and say in the last over there were 21 runs made. So in this 7 over match with the score of each over, this is the score or the data given. So in this situation, let's see how we can find the mean score. Now we have observed that in every over the score is not the same. It fluctuates. Sometimes it's high, down by 5 runs, and next down by 3 runs, next down by 6 runs, and again it rises to this. So this fluctuation of up and down of runs in each over when a cricket match is played is now investigated through the mean. So what does mean say? What is a mean? The measure of central tendency mean says that if I have the different scores in different overs, I can find the average score which a batsman makes in each over. So the average score is what we are going to seek in mean. So what is the average score made in general when compared to the runs as given in each over? So let's see the average. So here mean is defined as sum of all observations by total number of observations is how I define the formula for mean. Mean is sum of all observations by total number of observations, or mean is also referred as average. So let's see what is the mean or average for the runs scored in first 7 overs of the cricket match. So using the formula for mean or average being this by this, I have my mean, which is generally denoted by mu. Therefore, mean is sum of all observations 20 plus 15 plus 12 plus 6, 9, 5, 21 by number of observations is 1, 2, 3, 4, 5, 6, 7. So the total number of observations is 7. So when I add up 35, 47, 53, 62, 67, 88. So I get this to be 88 by 7, which approximately gives me 7 ones 7, 18, 7 twos 14, 0.40, 7 fives 35, 50, and then so on and so forth. So here, therefore, the mean of the given scores is approximately 12.6 or 13. That means I calculate that on average the batsman scores 13 runs in each over is how the mean estimates. So the average of this or the mean of this is 13, implies the batsman on average has been scoring 13 runs in each over based on the data as given here. Mean with the formula sum of all observations by total number of observations. Sum by total number equals 13. Now that we have discussed about mean in the previous example with runs scored by the batsman, cricket batsman in first 7 overs. Now let's see how we can calculate mean for a frequency table. This session is about finding mean for a frequency table. For a frequency table. For example, if I have a frequency table where I have the first column with mathematics marks as obtained in an exam, and this is the second column is number of students who have achieved these marks. Say for example, "60, 70, 80, 90 and 100. Say there were 3 students who got 60 marks, there were 2 students who got 70, there were 5 students who got 80, 2 students who got 90, and only 1 student who got 100. So in case of this kind of a frequency table, how do we calculate mean is the biggest question in the session. So for the math marks and the number of students who got those fixed math marks, let's see how we can find the mean for a frequency table. So when a frequency table is given, I have my mean, which says the formula is sigma fx by sigma f is the formula which I am going to use. So the mean or average for a frequency table is sigma fx by sigma f, where f is this and x is this. So the math marks here are referred to x, and the number of students who got those math marks are referred to the frequency f, where I can find the formula easier. So what I do is I extend one more column out here because I need fx. So now that I have x and f, next I would like to construct a column for fx. How do we get fx? This times this is f into x. So 60 times 3 is 180, 70 times 2 is 140, 80 times 5 is 400, 90 times 2 is 180, and 100 times 1 is 100. Now that I have got fx, next I need sigma fx. Sigma means summation, and hence I'm going to add all this. Because I need sigma fx, I can get sigma fx by adding each of fx in the entire column. So when I add up, I get this to be 8, 16, 20, 1, 2, 4, 5, 6, 7, 8, 9, 10. So, I got this to be a round figure of 1000. So sigma fx is 1000. Now next, I need sigma f. And sigma f is the sum of all frequency, and hence I add up all the frequency out here so that I get sigma f. 5, 6, 7, 8, 9, 10, 13. So here I have my sigma f and my sigma fx, which I'm going to find using mean formula. So my mean, which is sigma fx by sigma f, gives me sigma fx, which is 1000 by 13, which on further simplification gives. So now 1000 by 13, which is 13 sevens 91, and 90, and then 90 goes, 13 6 are 78, and then I get this to be 80, 12 120, and 13 9 2, etc. So this comes out to be 76.9 or 77 marks is how this. So what does this make me understand? It makes me understand that the mean marks in the class is 77 marks. So based on the entire marks and the number of students who got those marks in the entire class of 13 students, I can make out that therefore the mean or average marks obtained by students in mathematics subject is 77 marks. I can say this to be the class average. The teacher proudly calculates the class average to know where the students are standing or the overall performance is standing out here. Therefore, the class average is 77 marks in mathematics subject. Not a bad marks. The next measure of central tendency in the branch of statistics is median. Now that we have discussed about mean, let's enter into understanding the next measure of central tendency. This session is about median, the second measure of central tendency. What is a median? It is very simple. The most simple definition I can give for median is that it is the middlemost value in the observations. So if you pick the middlemost value, then that middle value is called the median. It is the middlemost value in the observations which are arranged in order ascending or descending. We have a rule here that the data has to be arranged in ascending or descending order. So let's see how the middlemost value is identified through an example problem. For example, I have the observation which is 2, 1, 5, 3, 9, 6, 8. Now this data is not in ascending or descending order. So the first thing I do in order to identify median is arrange in ascending or descending order. So let me arrange in ascending order. So when I order it 1, 2, 3, 5, 6, 8, 9. So how do we pick the middlemost value? I try to strike the first and the last, the second and the second last, third and the third last, then finally whatever is left is the middle value. So here this is the median because it is the middlemost value. So when I start striking, the middle value is called median. So for this problem, the median is 5. Now here, if we count the number of observations, 1, 2, 3, 4, 5, 6, 7, when there are 7 observations, then there's only one middle value. But if we have, say, 8 observations, say for example, I take the same example problem, 2, 1, 5, 3, 9, 6, 8 and 11. I have an additional observation. 1, 2, 3, 4, 5, 6, 7, 8. Now this 7 observations is added up with the 8th observation 11, and let's see how the median is understood for this. The first thing I do is I put them in order 1, 2, 3, 5, 6, 8, 9 and 11. Now let's pick the middle term by using the concept of striking off the first and last. The first and the last, second, second last, third last, but I cannot strike both, then there's no median existing. So here I have 2 terms which are tied. Here there's only 1 term and hence median is 5. But in this case I have 2 terms or 2 observations. What is the median? So generally when you have such a case arising, then we take the average of 5 and 6, which is 11 by 2, and therefore the median is said to be 5.5 is how we calculate. If we have 2 observations tied up, then we take the average, and that average is deciding the median value. So if we have the learning outcome out here is that if you have 7 observations, this being odd, you get the median value directly. But if you have 8 observations, n is even, then we have 2 observations tied up. So whenever n is even, we get a tie and we take the average. Whenever n is odd, we get only 1 single observation, which is the median. It's how we understand the concept of median being the middlemost value in the observations arranged in order, either ascending or descending order. Now that we have come across 2 different cases arised in previous example when n is 7 and when n is 8, has given us a new concept of understanding that there are 2 cases which arise when you calculate median. Case 1, n is even. Case 2, n is odd. So here, let's see the formula for calculating median. So assuming that there are n observations, for n observations, case 1, n is odd. If n is odd, implies median is n plus 1 by 2th observation. That's how we understand the formula. Median is n plus 1 by 2th observation, where n is the value, which is the number of observations. Case 2, n is even, implies median is average of n by 2 plus 1th and n by 2 plus 3th observations. Is how we understand. N odd, median is n plus 1 by 2th observation. N even, median is average of n by 2 plus 1th observation, and n by 2 plus 3th observation. Is how we understand the 2 basic formulae for n observations, median with its formula. Now the third and the last measure of central tendency is mode. This session is about the central tendency mode. Let's recap with mean. Mean is the average of all observations. Median is the middlemost observation, and mode is most frequently occurring observation. To give in the most simple definition, mode says it is the most frequently occurring observation. It's the most frequently occurring observation. That means if the frequency is highest, then that value, that observation is said to be the mode. We can also refer to this as mode is the observation value which has highest frequency. It's simple because when the observation value has highest frequency, that means it repeats for most number of times. Therefore, mode is the most frequently occurring observation, or mathematically mode is the observation value which has highest frequency. Let's take an example. For example, 5, 3, 7, 1, 3, 9, 6, 3, 9, 5, 3, 8, 9. Let's see what is the highest occurring value. As we can clearly see that this 3 occurs 1, 2, 3 and 4 times. Since most occurring observation here is identified to be 3, when you take any other observation is always less than 3. Therefore, most occurring by definition we say the mode is 3. Is how we define the most frequently occurring observation being 3 in this example, and hence the mode is 3.